So let's start part 3 of workshop number 3. So here in this part, we're going to do real queries. And we're going to do a bit more complex queries than the first example of the search for cats we did. So this is the first query we're going to do is that we're going to find all the jobs performing subclasses of performing artists. So a performer actor is someone it has many occupation that can fit this criteria. So we're going to ask Wikidata to tell us what job it knows that are a subclass of performing artists. So, we're going to have first a variable which is called the V class, which is going to contain the subclass of performing artist. And we're going to have a V label variable, which is going to contain the name of the job. So basically, this query requires the property P279, which is subclass of, and also performing artist, which is Q 713200. And okay, just so that you know, open the link that is below in this page, because this will, whoops, I'm gonna close this, open it back. So now you see it has done the search. One thing here is that you got to go to edit Sparkle to get back the query, and you can re-execute it by pressing on the blue triangle. Now, you see the result is shown below. Now, there's like I said earlier, the variables, when they're put in select, it gives you the column of your results. So the first variable is V class, and our first column is V class. The second variable is V label, and the second column is V label. So it's really a one-to-one. One other thing you can see here is that you've got above the results, you've got the total number of results that are shown, and how long it took for the engine to do this search. Now, this is very important time, because if it exceeds 5 seconds or 5,000 milliseconds, your query is going to give no result at all. So you really have to make sure you don't go above 5 seconds. There is the code to integrate into HTML the results. And you also have a download button where you could download the results into a file. It could be a CSV file. It could be a table separated value file. Sorry. It could be also a JSON, a HTML table. And you also have the link where you can ask for short links. That is what I use when I put links into the presentation. I use this function to get a short link, which brings me back to the result page where I can go to the query, the Wikidata query. So that's basically it for this subclass. There's a little detail I want you to see, but I will not explain it totally. But here you have a star, an asterisk at the end of the property. This tells us that not only do we want subclasses of performing artists, but we also want to have subclasses of subclasses. Now, this is a bit tricky, and I won't go into the details, but imagine that a performing artist could be a clown, but they could be a special kind of clown which is a particular clown, let's say in Japan or in Germany, they have this kind of clown in their culture, which is a clown, but it's a particular clown. So basically you can have jobs that are subclasses of subclasses, but with the star, it will not stop at the first level of subclass. It will go as long as it can in other subclasses. But this is a concept we'll see further in another workshop at the end, but you don't, it's something you don't really use necessarily very often, but it's important to know because you'll see it in some queries. Now, the next example, you can also open it. So there's a link at the bottom. So once again, choose Edit Sparkle command at the right of the screen. This gives you the code and you can relaunch the request. You can relaunch the request here. So this one is longer. So this one takes 4,500 milliseconds. So you see we're close to the limit here. Oops. So basically, how this query is built. First, like in the preceding example, what we're going to do is we're going to find all the type of jobs that are subclasses of performing artist. So that we're going to store that into the V occupation variable. Now, the next line is we're going to find artists which have like occupation, one of the founded occupation in the preceding triplet. So we're actually asking to find all the artists that have those occupation. And the last one is actually a criteria to narrow our search, because we only want Canadian artists. We don't want artists from the world. So to tailor and narrow our result, we use the property citizenship, and we use the country Canada. So this will only give us artists from Canada. So that's the third triplet that is used to enter that criteria. So here is another way of saying the same thing as I shown you before. So the first line, and here it emphasizes, it show really that those are triplets. So the first part is the main element of the triplet. The second part is the property, and the third part is the value. So here, what is interesting to understand is that variable can be in any position in the search, and there could even be two variables, and in some case actually it could be all variables, but basically often you have one or two variables. Now in this example, the first one is putting all the occupation that are subclasses of performing artist into the first variable. And this first variable is used afterward as a value for a second triplet. So the main entity of the triplet is any artist, which is a variable that Wikidata will find. And the property now is occupation. So we want artists that have occupation that are a type we search. And we have the last triplet, which is a simple triplet, which is actually says that, well, every artist must be citizen of, must have the country of citizenship, that is Canada. So, and this is a third diagram or a third way of showing exactly the same thing, But now I'm showing more the links between the triplet. So we have two triplets that have actually the same main element. And one of them is just like to get the citizenship country, and the other one is to get occupation. But occupation, the value of this triplet, is actually also the main entity of a third triplet. And this triplet is the one that, of course, is searching for all the jobs that are subclasses of performing artists. So here's now the result. Here I want to see bubble chart as a result. So this tool in the result part of the window, you can choose bubble chart. And bubble chart is a special way of showing the result. Instead of giving us a table, a straight table, you have like dots, which are the size of the dot is controlled by a number. So if we go back to the table, if we go back to the table result, we can see we have a column which is called count. And this table actually is column, and this column actually has a number of artists that have this kind of job. So for entertainer, there are 7 into Wikidata, but in Canada also. Remember, there's the criteria for, so we see we have 184 comedians, and I think we also have some theater actors. But let's go back into the bubble chart results here and see we have dancer, comedian. So stage actor. Stage actor is what is the most common into Wikidata, with conductors also. So basically, this is a bubble chart result of a Wikidata query service search. So here, I want to show you here the count. In this query, we've used what I've talked about earlier, which are actually group by. And now group by, what it does is that it concatenates lines together. So it gives us into the occupation, it gives us many answers. So here I create a new value, which is a new variable, which is called count. And this variable actually contains the number of items. So when it will concatenate many lines, the quantity of values that are going to be on this, the same line are a count of actually of with the function count here. So this gives us the value in the last column, which is actually a count. We can do the same search, but if we put a dash character before this line, we invalidate. We say to Wikidata, this is only a comment, and well, what it will do is it will give us the result, but for the world, not only for Canada, but for every, actually, not only the world. If there were other people in the universe that entered into Wikidata, they would show up on this search. So basically, it's just to show you how it's easy to add or remove a criteria for a search. And if we go into the result, we can see now still the same proportion worldwide about stage actor and conductor. They are still the main job, performing arts job that for people that are entered into Wikidata. So this is basically for the second example. now we have a new query here. So I also recommend you open it in a new window. So let's do this here. Excellent. So basically, what we've done here is we ask Wikidata query service to show us on a map where are the theaters in Canada. So we see there's one close to Alaska. We see that there are more here around the St. Lawrence and the Toronto region. We see that there are more theaters. So this way of showing graphically the results sometimes talks more than having just a table of rows. And so basically that's the strength of this Wikidata query service, is that you're enabled to choose how you display this data. Now, I want to open to you another use that can be done for that. One important thing is that so this is created in real time with data that is actually into Wikidata. So, but you could, like I showed before, it is possible to integrate. Let's try to. Let's go into the edit mode. Let's relaunch the search. Now, see, you have code here. Now, this is code that you can, depending on which one you use, like the iframe is something you can put straight into your website, your own website. So that means you can create a particular query that will search what you want, and then you can integrate that into your website. And what does it means is that each time someone is going to load the page, the data is going to see on the map or any way it's displayed. This data will come straight from Wikidata. So this is both good and bad. It has good side and bad side. So the good side is that you don't have to keep the accuracy of your own data. As long as you keep it, make sure in Wikidata it's current, then you know that on your website it will also be current. Which means that if other people add information that fits your criteria research, then those will appear. But it also means that if you use that feature and someone does vandalism on Wikidata and it's there for 2 days, well, if that information is in your result, then of course it will also be bad on your website for 2 days. So you're dependent on Wikidata if you choose that. But for simple things, it's very, very useful and very powerful. And it really removes the burden of having to yourself keep your website up to date for a particular thing. It is done through Wikidata, and Wikidata is much more kept to à jour, up to date. Sorry. Okay. So I will talk a bit here about the service because I scratch a bit the surface, but let me explain to you how this works. So basically, service is a tool that takes your variable and it creates a second variable that instead of having the Wikidata identifier, it gives you the label. So let's see this result, but not with a map, but with a table view. So now we can see that the first column is the Wikidata identifier, but it also has a link. So this is very useful. We could use the link to open. And there we see we have Théâtre Saint-Denis. But the label is actually given by the service into the second variable. Just because we use the same variable name, added label with an uppercase L, then we have this column that contains the label for the first item. Now, the third column is the geographical coordinate. Now, this is extracted with the P625. Now you see this, it is not, this value is not textual value. It's actually an internal format which has two numbers, so latitude and longitude. But it's displayed by the Wikidata query service as a point of two numbers. So it's a particular type of value. And when you have a column with this type of value, well, if you go into table and you choose map, then, then it gives you a map with the coordinate as a pin on this map. So it's really powerful. Now, I've talked earlier, when I talked about the variables, I've talked about some, like this one is default view, semicolon map. And this is really what makes the query in the first time it is run, it makes it display as a map. If we wouldn't have that, then it wouldn't, it would only show like the standard column results. Okay. For the Wikidata label service, I skipped a little part which can be useful. One advantage of this service is that it defaults, if you don't have the language you ask for, it can try with another language. And it can do that, like there's no limit to the fallback languages you can put. So auto language is actually the language of your interface. So you have English, I'm using English now, so auto language would be English, but I've stated also that the second is really English, so, and the third would be French. So if there was no English label or description for this, then it would take the French label. And if there's no French label, then there would be none at all. So that's for a description of this service. Let's go back here. So like I said here, the command to display as map is here. We've extracted with P625 the coordinate, and we choose only to limit to Canadian, to theater located in Canada. So the P17 is actually, it is not the one used for human, it's really the one used for businesses, or in our case here, we're talking about the building. Oh, this is something also very, very important. I was going to go over it. When we're searching for theater, theater can be an art, but it also can be a building. But those are two different entities into Wikidata. So you really, really have to choose the entity that is of the physical location and not the art of theater. So this is a detail, but it will give you bad results if you don't take care of it. Okay, so basically, we have a diagram showing us in triplets. So basically, we have three triplets for this query. So the first, we want to fill the variable theater with all the items that are instance of, and here it's the theater, but the building one. And then the second triplet is we want, for those theater, we want to extract the geographical coordinate, and we want to put them in a second variable. So this is called v coordinates. Like I said, you can give whatever name you want to your variable. So that's the one I chose. I personally always use a small case v before my variable, but this is very, very personal. It's not an obligation at all. And of course, the last triplet, which is, okay, only show me theaters that are in Canada. And this gives us our results here in the map with all the dots, the red dots that are representing the theater. So this is basically the end of part 3 of workshop number 3. So I'm ready for your questions.
Hello. So we have a couple questions. Trying to go back because there was one from Sandra. So that's a very good one. Sandra writes, my 7 children results took 31 milliseconds. Milliseconds depends on internet connection, or is it linked to the Wikidata server and coding we include in the query?
Interesting question. Okay, basically, it's not the network. Why? Because the network, you're only sending like the text query to the server. And this is really like 1,000 character max, or 2,000 or a few thousand character, which is 1K or 2K, which is very, very small. And the result when they come back, they're also small. So compared to the inner working, because when you do a query, you must understand that Wikidata is going to try to match your query with, I think we're at 80 million of Wikidata item now, or something like that. So it really has to check in its internal database if this match every triplet it stores. So of course there's optimization and all indexes and all the good way to make that fast, but still in essence this is the hard work, is to compare with the Wikidata bank of data. So no, it's not the network. Even if you have the 57K modem, it would still not be the issue here.
So we had further questions about how geocoordinates for a specific venue can be found. I tried to answer them to Jean-Robert over the chat, but as I was saying, there are a number of different ways that we can actually generate the geocoordinates. What's your take? What would you recommend?
You mean to add a geographical coordinate inside a Wikidata item?
Or to find them, to know what the actual geocoordinates are. Because as some people might know, there are different ways that geocoordinates can be provided into a geolocation system. Google used one method, one standard, and Wikidata uses another one. So you can't quite rely on your Google My Business to get the exact answer you need. You need to convert that into the other formats. So there are geocoders, free geocoders that you can use over the web to just take information in one format, or simply take an address and get the geocoordinates for that address. Jean-Robert mentioned OpenStreetMap. What would you recommend, Antoine?
Well, see here, I don't really have a preference for that. I mean, it's beyond the scope of this workshop, but I will give you some answers. I personally use a lot Google Maps here. Like,
you have it there. You're right.
Yeah. So let me show you how I did. So I searched behind Q. Now behind Q is
the red pin.
The red pin, it's behind Q.
The red pin, yes, the red one in the middle. Yes.
It was too big. So the second thing I do is I go and show more information on that spot. Then I have this here. And if you click on that, it will put in the URL both ways of entering the same same coordinate. So you, but it's
Okay, so it is possible to use Google Map for that. So it's a good to know, because I was under the impression that because schema.org uses a different standard, that somehow Google would not really help us get this kind of information. But it's feasible. Good to know.
yeah, and in the two ways also, because sometimes if we go after, let's say we add a value here. So the thing is, in Wikidata, you add them like this. So you see, I had to remove the plus. I had to remove the n. I copied too much, but this is okay for that Wikidata, and this is we could store it.
Good.
But that's really it's not the easiest way, but it's like probably the fastest way, like for me. So, but I don't I'm not like saying Google Map is better than Google Map is better than OpenStreetMap. I encourage people to use OpenStreetMap, and OpenStreetMap is at many levels connected with Wikidata. So it's really a good partner for Wikidata. So I would suggest you go into OpenStreetMap to find that information.
And if the venue doesn't exist, is not already pointed on the map, then you can add it in OpenStreetMap, while in Google Maps, I don't believe you can.
The contribution to Google Maps is much harder, but it's also possible with Google Maps to become a member of that community. But there are far less people, and people in OpenStreetMap are much more funnier. Anyway, I have a bias for OpenStreetMap. Let's be honest here.
Thank you.
So we had another question from Nathalie Thibault, who is trying to achieve to perform some very specific advanced queries, and I dare suggest that she contact you over email and ask you exactly what she's after, so you can help her write her query.
Yeah, it will be a pleasure for me to help you.
Excellent. I think we're through with the. Did I leave any question unanswered? I think we're through. So perhaps it's time to revisit the earlier question. What can you use it for? So we saw a few examples of how it could be used. With the map, one of the most obvious use case that I can think of is for example, for municipalities. Municipalities will occasionally conduct a cultural mapping exercise to find out what cultural assets they have on their territory. Usually it's done with a one-time data collection, and then it gets outdated, and eventually they have to do the process anew again. Municipalities from now on could decide to simply use Wikidata to perform to realize their, and also to display their cultural mapping, and hope that over time the owners of those items, if I may use the word owner, because then there's no such thing in Wikidata, if the organizations for those items would maintain the information over time, then the map remains up to date over time. That's one of many different use cases for Wikidata queries, but there can be many, many more. Does that answer your question? Because I can come up with plenty of answers for you. Are there further questions?
If we still have time, I might have one.
Sure.
Antoine, you mentioned the fact that if we use an HTML code snippet in a page to display a query, but that the query goes sour or goes bad or goes out of sync at some point, that it will affect the rendition of the results in our page. Is there a way to mitigate that, like some sort of buffer which will only refresh when you ask it to refresh, for example?
No, there are no such thing. Now, nothing would prevent you from taking a copy of Wikidata, making your own Wikidata and copying data from Wikidata at one point, and then maintaining your own Wikidata. I mean, this is all open. This is all it just costs time, not money. But of course, time is money. But like, you could do yourself a wiki, your own Wikidata, and grab data, like update it from time to time. But I really doubt anybody would do that. Personally, what I would do to make sure I have a better control over the quality, I would in my request, I would do a much more complex request that would make sure that the reference for the declaration that are shown are either from me or from a source I know. So that way I would only present data that are that has a good reference. Is that clear?
Yeah. Yeah.
So, and of course, if someone finds out that this is the way I'm working and he creates a new declaration that has the same source or the good source that I'm checking, of course he can fool me. But that would be harder. He would have to have an inner knowledge of my request, how it is built, and so that would make it stronger and less prone to change from a simple mistake. But it is not perfect, because even if I put references, someone can edit the value without changing the reference, and that will, well, I would need a stronger mechanism to validate, and so.
Mm-hmm.
I mean,
sorry.
So there is no way to actually block a refresh and just trigger it just once in a while, trigger it manually, make sure in the meantime that nothing has been.
Whoa! Never say never to a computer guy. This is you're going to trouble. I mean, of course there's a way to do it. Nothing would prevent you from putting it on one page, generating it, copying the HTML that is done afterward, and putting this static HTML into your web page. So basically, you would take a copy of it, and that copy would be static. But it's much out of the scope of this workshop, so I don't want to.
I was just about to try to bring us back to the topic. We have another interesting question from Caroline, who would like to have more examples of how Wikidata queries can be used for what purposes.
Okay, so I just want to add for the question of Jean-Robert a small detail. Personally, if I was to incorporate into with an element like a car, a map or something like that, something that with data that comes straight from Wikidata, I would make sure to put a line afterward saying this data comes from Wikidata, which is actually, it protects you, because if bad data are in Wikidata and they get shown on your website, well, at least people know that it comes from Wikidata. So if the data is bad, well, the data is bad from Wikidata. I would put a line specifying the source of this in my website. Now, for the next question, there are plenty of examples. And I really encourage you to go and try it and look at them. If you go into example, me, I always take the first one to start a query, but look at the quantities of queries that are here. Those are all good
I think
examples.
Kevin is actually not looking for example, but purposes of such examples. So let's say, for example, you would like to know how many plays performed in Quebec in the last year were staged by a female theater director as opposed to a male. It's time we see more plays being staged by women. There's a way to write that as a Sparkle query. Now, the big question is the data we're looking for actually present in Wikidata? If it's not there, you may actually be able to write the query and get the results, but the data will not be complete enough for you to have the full picture. And that's why we're making this series of workshops and inviting people to provide data into Wikidata. This is like one of many use cases. Just come up with a wicked question that you like answered. There's a way to write it in Sparkle. But then the next big thing is the data actually available in Wikidata? And was it populated properly with the right properties and values that it will actually be found by your query? That's another thing. So again, training is part of solving the completion and data quality issues in Wikidata.